So today we'll discuss some of the QA manager interview questions. So this is for candidates who are looking for QA manager roles. They might get this kind of scenario-based questions in the interview calls. So let's get started. So first question you might get is what is the um, STLC model you have followed in your company? So before we discuss about waterfall model, interviewer might ask you like what is an STLC? STLC stands for Development Lifecycle. It is a process used for software development teams to design, develop, test, and deploy high quality software products. The STLC framework provides a systematic approach to software development and ensures that software is developed efficiently and effectively. So, some of the phases for SDLC are like planning, analysis, design, implementation, testing, deployment, maintenance. And SDLC is often depicted as a linear process, but in practice, it is often iterative and incremental with feedback loops between the phases. Now, this allows for flexibility and adaptation to changing requirements or circumstances throughout the development process. Additionally, various methods such as Agile, Waterfall, and DevOps can be used within the SDLC framework. So, now you have understood like SDLC is basically a developmental cycle, okay, and it consists of several like um methodologies such as Agile, Waterfall, DevOps in the SDLC framework. So depending upon that, company might choose. So some company might choose waterfall model, some company might choose agile model. So you might be asked like, what is an agile model? What is a waterfall model? So one of these questions is what is the waterfall model phases and its advantages. The waterfall model is a sequential software development process. Okay, and process model where progress is seen like flowing steadily downwards like a waterfall through several phases. Each phases must be completed before next phase begins. So to understand, waterfall model is one of the earliest and most straightforward approaches for software development. In this model, development process is divided into sequential phases, with each phase dependent on the deliverables of the previous one. It follows like a linear and systematic approach where progress flows steadily downwards like a waterfall through these distinct phases. So these are the phases you can see: requirements gathering, system design, implementation, coding, integration and testing, deployment, installations, maintenance. So these are the models and these are the phases, and we'll discuss each of these. Requirements gathering and analysis. In this phase, requirements are gathered from stakeholders and analyzed to understand the scope of the project. Next phase is system design. Based on the requirements gathered, the system architecture and design are created. This includes defining system components, interfaces, and data structure. Implementation or coding. In this phase, the actual coding or development of the software takes place. Developers write code based on the design specification. Testing. Once the implementation is complete, the software is tested to identify and fix defects. Testing activities including unit testing, integration testing, system testing, and user acceptance testing. Next is deployment or installation. After testing is complete and the software is deemed ready for release, it is deployed to the production environment. And finally, the maintenance. In this phase, updates, enhancement, and bug fixes are made as needed to ensure the software continues to meet user needs. Okay, so this is the details of waterfall model phases. Now, next move to the next slide. So here also I have mentioned explain the phases of water model. And you can see we just discussed these pages: requirements gathering, analysis, system design, implementation, coding, testing, deployment, and maintenance. So if you are working in QA manager, you have to basically focus on the testing phase because that's the phase where QA normally does their work. testing softwares once implementation coding phase is completed. Okay. What are the advantages of water model? It is simply and easy to understand. The waterfall model is easy to understand and users, making it suitable for projects with well-defined requirements. Next is clear documentation. Each phase produces specific documents, providing clear documentation for each stage of the development process. Stable requirements. Since all requirements are gathered and defined upfront, there is less likelihood for scope creep or changes during the development process. Sequential approach. The linear and sequential nature of the waterfall model makes it easy to manage and track progress. So there are some disadvantages also in the waterfall model. So we will just highlight few. First is rigid and inflexible. The waterfall model is rigid and inflexible, making it difficult to accommodate changes once the development process has started. Next is limited customer feedback. So since customer feedback is not obtained until late in the development process, there is a risk of delivering a product that does not fully meet user needs. High risk. If requirements are not accurately gathered and defined upfront, it can lead to significant rework and delays later in the development process. Long delivery time. Due to its sequential nature, the waterfall model can result in a long delivery times, especially for large and complex projects. So there are few disadvantages we just saw. First is there is a risk that if there is a requirement change, it will be significantly delaying the project, and thus one of the high cost bearing activity, which is like the time consuming process, since you are changing the requirements at the later stage of the project. So overall, waterfall model is the best suited for projects where well defined and stable requirements are present. So once requirements are fixed, you are not expected to change the requirement again in the waterfall model. Okay, this is a thumb rule in waterfall model. You cannot change the requirement again. Okay, and then it may not be suitable for projects that require flexibility, rapid iteration, frequent changes in the requirements. So waterfall model is not a suitable um, model, SLC model, for projects which require flexibility and iteration or frequent changes. That's how agile concept has come out of it, because most company require some flexibility so that they can keep the requirements in the product backlog and then pick it up whenever it's needed. Okay, but there are companies who still follows waterfall model, and as such in their release process. Okay, now next question we will ask, like, let's say, what are the responsibilities as a test lead, or let's say as a queue manager you will take care in the waterfall model. So in the waterfall model, the QA manager or test lead normally plays a crucial role in ensuring the quality and success of the project by overseeing the testing process. Okay, the key responsibilities of a QA manager in the waterfall models are like test planning. So you will create basically a test plan. So test lead is responsible for creating the test plan and outlines the testing approach, scope, resources, schedule, and deliverables. The plan should also define the testing strategies and methodologies to be used. So that's one of the major responsibility. Then requirement analysis. The QA manager mainly works closely with that business analyst and stakeholders to understand the project requirements. Okay, they ensure that the requirements are clear, complete, and testable. Test case design. Based on the requirements and design documentation, the QA manager oversees the creation of test cases by the testing team. Okay, they ensure that test cases covers all the functional and non-functional aspects of the software. Test environment setup. The test lead is responsible for setting up the test environment, including hardware, software, and test data to mimic the production environment as closely as possible. Then the test execution. The test lead is basically coordinates and monitors the execution of the test cases by testing team. They ensure that tests are executed accordingly to the test plan and reports any deviation or issues to the stakeholders. Next is defect management. So the test lead oversees the defect management process, including defect identification, logging, tracking, prioritization, and resolution. They work closely with the developmental team to ensure timely resolution of the defects. Test reporting. The test lead prepares test reports and communicates the testing process, results, and issues to the project stakeholders, including management and clients. They provide regular updates on the status of testing activities. So this is the major responsibility of test lead or queue manager, that you should be reporting the status of your work to the leadership teams or stakeholders. Finally, quality assurance. The test lead ensures that the testing process adheres to the quality standards, test practices, and industry guidelines. They continuously evaluate and improve the testing process to enhance efficiency and effectiveness. Risk management. The test lead identifies potential risks and issues related to testing activities and develops mitigation strategies to address them. They proactively manage risk to minimize their impact on the project. Finally, the team management. The test lead provides leadership guidance and support to the testing team, including assigning tasks, monitoring progress, providing feedback, and resolving conflicts. They foster a collaborative and productive environment. So overall, basically, test lead or a QA manager plays a critical role in driving the testing effort and ensuring that the software meets quality standards, okay, and customer expectations in the waterfall model. Okay, they serve as a bridge between the development team, testing team, and project stakeholders, facilitating effective communication and collaboration throughout the testing process. So these are some of the responsibilities of test lead or QA manager. So right from testing planning, test case design, requirement analysis, defect management, test reporting, quality assurance, team management. There will be a team handling activity also, apart from the test checking the test planning and test coverage. So let's move to the next question. What are non-functional requirements? So non-functional requirements are nothing but requirements that are basically suited for performance, scalability, reliability, and like usability, security, okay, and maintainability, compatibility, okay, portability, and efficiency. These are like non-functional because they don't basically covers the functionality, but they checks the performance of the system or requirements. Okay, so the non-functional requirements basically are also called as NFRs, define the quality attributes, performance criteria, and operational capabilities of a system. Unlike functional requirements which specify what the system should do, like the non-functional requirements specify how the system performs those functions. Okay, NFRs are crucial for ensuring that the system meets certain standards and provides a good user experience. So some of the key categories as I listed, like performance, which should cover the response time, the time it takes for system to respond the user inputs, throughput also, the number of transactions or operations the system can handle in a given time period, then capacity, the maximum number of users or amount of data the system can handle. Next is scalability. So scalability will be like there are two types of scalability: horizontal scalability and vertical scalability. The horizontal scalability basically is the ability to add more machines or server to handle the increased load, whereas vertical scalability will be the ability to add more resources like CPU or memory to an existing machine to handle the increasing load. Okay. Next is reliability. Like availability is the mm, criteria for checking the reliability, like the portion of time the system is operational and accessible. Okay, the system must be in the uptime of 99.99%, and mean time between the failures, like Average time between the system failures we need to check, and the average time taken to repair the system after a failure, that also we need to check. Then next is usability. Usability means like new users should be able to complete the onboarding process within 5 minutes before assistance, without assistance. So in this case, we will check mainly ease of use, how easy it is for users to learn and use the system. Then user interface, the design and accessibility of the system interface, and then user satisfaction, the degree of which the user is satisfied with system performance and measures. Okay, so user interface basically, when you're building an application, we normally check like whether buttons are properly aligned or not, whether texts are properly aligned or not, whether logos are properly aligned or not. These usability features, which normally get caught during the UAT, right? User acceptance testing. So we'll check that user interface meets the customer requirements. Then security, like all data must be encrypted in transit and at the rest. Like it should check the confidentiality, like ensuring that system information is accessible only to those authorized to access it. Integrity, ensuring the accuracy and completeness of the data. Availability, ensuring that system and data are accessible when needed. Authentication and authorization, ensuring that users are who they claim to be and have appropriate access rights. Then maintainability, modularity is one of the criteria, like the degree to which the system components can be separated and combined. And then reusability, the extent to which system components can be reused in other contexts. And analyzability, the ease with which the system can be analyzed for faults and performance issues. Then testability, the ease which the system can be tested or ensure it meets the requirements. Then compatibility means like system must be compatible with the latest version of Chrome, Firefox, and Safari browser. Normally, what happens when you're upgrading the browser, system is normally provide some exceptions, errors in the content which need to be fixed. So that is the reason we will check the compatibility. So and then portability, system must be able to run in both Windows, Linux operating system. Okay, this means that users who uses Linux can access the system. Users who uses Windows can access the system. So that's basically bringing more usability or more user access. Okay, that's why we call it as a portability. Okay, and efficiency. The system must process data with no more than 70% of available CPU capacity. So it's like resource utilization, the degree to which system efficiently uses resources such as CPU, memory, and network bandwidth. Performance optimization, the degree to which system is optimized for speed and efficiency. Okay. The importance of non-functional requirements can be in the quality assurance, like it ensures system meets performance, security, and usability standards. User experience is also important, and system reliability, it ensures that system is reliable, maintainable, and available when needed. Cost management, and a non-functional requirement basically helps in identifying potential cost associated with maintaining and supporting the system. Compliance ensures adherence to legal and regulatory standards. So by carefully defining and adhering the non-functional requirements, a project can achieve a system that only meets the functional goals but also performs like that not only meets the functional goals but also performs efficiently, securely, and reliably to the real world conditions. So, just by testing functional requirements is not enough. The system should be performing well also to make sure like it's adhering to the process, and users will should have a good experience in terms of performance. Then only we must say it's a stable product, right? So that's why non-functional requirements are very important. We'll move to the next. So next very important concept question that you might get is what is traceability metrics. So traceability metrics is a very important questions, and like it's a document usually in the form of table that maps and traces user requirements, with the test cases designed to validate those requirements. The primary purpose of a traceability matrix is to ensure that all requirements defined for a system are tested in the test protocols. It helps in ensuring that there is no functionality missing and that all requirements are covered by test cases. Here's an overview of what traceability includes and its types and benefits. So first is a traceability matrix is a document actually, and it should have a requirement ID, like it's a unique identifier for each requirement, usually taken from the requirement specification documents. Okay. And requirement description, a brief description of the requirement. Okay, these things you will be getting from the functional requirements document, FSDs. Okay, then you should have a test case ID, the unique identifier for each test case designed to test the requirement, and test case description, a brief description of the test case, test status, the status of the test case, like passed or failed, in progress, not executed, defect ID, a unique identifier for any defects found during testing, linked to the test case and requirement, and finally comments and notes. Any additional information, observation, or notes. So these things we should be mentioning in the traceability matrix document. Now there are some types of traceability matrix, like forward traceability matrix. It basically maps the requirement to the test cases. It ensures that all requirements are covered by test cases. And then there's also one called as backward traceability. It maps test cases back to the requirements. This ensures that scope of the project is not expanding by adding unnecessary tests. Okay, and that all tests are for the specific requirements. Then another is bidirectional traceability. So it basically combines both forward and backward traceability metrics and ensuring that all requirements are covered by test cases and that all test cases are linked to specific requirements. So traceability metrics had some benefits. You also need to tell the interviewer, like it ensures coverage and it tracks the requirements. And if there's any gaps, it should be identifying the gaps, like missing requirements or test cases, ensuring that nothing is overlooked. And it facilitates impact analysis, and definitely it improves quality. That is, it enhances the overall quality of the software product by ensuring thorough validation of all the specified requirements, and it streamlines communication. Basically, it acts as a communication tool among the project stakeholders. So everybody will be following the traceability metrics, including the customers, project stakeholders means the developer, tester, peer manager. Everybody will follow traceability metrics. So it's basically a document that communicates. Okay, and it basically provides a clear mapping of requirements to the test case. So in conclusion, like traceability metrics is a vital tool to ensuring that all requirements are tested and validated, providing confidence that software meets the specified needs and quality standards. And traceability metrics also an integral part of the quality assurance process in software development, particularly in structured model like waterfall model. It's very important document. So I hope these interview questions helps friends, and please keep revising the questions. Thank you for watching my channel. If you like it, please subscribe and hit the like button. Thank you, friends.